Okay guys, let me solve this. So, this guy gave me a comment and a suggestion to find the integral from negative infinity to infinity of e to the negative x squared dx. So his little tip he gave me is that if you set this to be equal to I squared is equal to negative infinity to positive infinity e to the negative x squared dx times, you could just use y e to the negative y squared dy, which if you combine the integrals, which actually I just learned in school very recently, actually today we went over part of it, dx dy, this is equal to I squared. Actually this is not equal to I squared. If you multiply these, you can actually add the this thing, what is it called, the exponents. You notice anything cool about this? If you take out the negative, it'd be x squared plus y squared. And what do you know about x squared plus y squared? This, and as this guy gave me a little helping hand with, is r. X squared plus y squared is r squared. So that means we can replace that with r. With e to the negative r squared dx dy. And how do we integrate r with respect to x and y? That's where this polar coordinates come in. We have to replace dx dy, that's equal to r dr d theta. And then we just need to find r and theta with respect to negative infinity, with negative infinity. And that, so if we take r, I don't know if you do dr, but it'd go to from 0 to infinity. And theta, of course, goes from 0 to 2 pi. I believe it goes to 2 pi. Yeah, that makes sense. So this is equal to, it'd be dr in the inside, so 0 to 2 pi of 0 to infinity of e to r squared r dr d theta. Now we just differentiate, or we integrate. If we can see that this is u sub, u is equal to negative r squared, du is equal to negative 2r dr. So negative 1/2 du is equal to r dr. So if we're just doing this inside integral, then we get negative 1/2, and then of course u of 0 is 0, u infinity is infinity, so just from 0 to infinity of e to the u du, which is negative 1/2 e to the u, from infinity to 0, which is just equal to I see what I did wrong. This is to negative infinity, because r squared, infinity squared is infinity, make that negative is negative infinity. E to the negative infinity is 0, and then minus, that would be e to the 0, which is 1. So minus 1 times 1/2, so just 1/2, which is equal to 1/2. Now we replace this with 1/2, so we just get the integral from 0 to 2 pi of 1/2 d theta. I think. Does this make sense? Yeah, it makes sense to me. Do we need to have theta in here? I don't think so. So that's just 1/2 theta. From 2 pi to 0, which is equal to pi minus 0. Just to make sure we did this correctly, e to the negative r squared times r dr d theta, which is negative infinity is in fact 0, 0 is in fact 1, then e theta, yeah, I mean, this seems right. I'll look at the correct answer. Let me look at how to do it. How to integrate e to the power of negative x squared from negative infinity to positive infinity. Positive infinity. Yeah. This is called the Gaussian integral. It's not solvable by elementary functions. And then they did do that, and they said, oh, that's cool. They did it. They said x is equal to r cosine theta, y is equal to r sine theta, and then that just gives you dx dy is equal to r dr d theta, which is, yeah, what I did. And then, what? Oh, I forgot to say this is equal to I squared, so I need to take the square root of that. Anyways, they said separate the integrals. Separate the integrals. How'd you do it that way? Multiplying them. Wouldn't you do inside, outside? Oh yeah, they got the same thing. I just forgot to say, going back and thinking about it, this is equal to, was my original answer, but this is actually equal to I squared, which means that I is equal to the square root of pi, which is the final answer. But I pretty much got it, I just forgot that small minor detail. But thank you guys for watching, and thank you for this gracious comment. I'll see you guys tomorrow. Goodbye.